Hello and welcome everybody to a very special Dreamspace Live as we celebrate Maths Week. And thank you so much for joining us. I'm going to be one of your hosts, Michael from the Microsoft Ireland Dreamspace team. I'm also joined this morning by Lorraine.
Hi
Welcome,
guys,
Lorraine.
how are you this morning?
Are you excited for Maths Week, Lorraine?
I'm really excited for Maths
Lorraine,
Week.
you definitely love maths. Can you tell us a
I
little bit
do.
about your relationship with maths?
So guys, I am actually a maths teacher. So even though I love coding, my true love is maths. So I'm really excited for this week.
Very cool. And actually, your love of coding, your love of math is going to be a perfect kind of segue into what we're going to be looking at today, folks. So let's take a quick look. First and foremost, we're going to be understanding the link between mathematics and coding. I'm sure a lot of you joining us have a lot more experience with maths than you do with coding, and that's perfectly a-okay. That's the perfect kind of foundation to set yourself up on for journeying through computer science. So we're also going to be looking at concepts such as probability and multiplication and how we can actually bring those to life through coding. And we're going to be looking at those connections throughout the entire event today. So that's going to be really exciting.
Exactly.
Next of all, Lorraine?
Next, we're going to be using problem-solving skills. So we're going to use word problems to kickstart our journey into coding, and this is going to help us enhance our logical thinking skills.
That's going to be excellent. And I'm sure a lot of people joining us are already celebrating Maths Week in a big way. And what I love about maths, I always loved it, was kind of word problems. So we're going to be looking at some of those today as well.
Yeah, definitely.
But you mentioned there logical thinking, Lauren. That's going to come up a couple of times throughout today's workshop. What does logical thinking mean?
So Michael, basically all logical thinking is just thinking in a sensible way, following kind of a step of rules, and then coming up with a solution that makes sense.
Okay, very good. So just thinking sense, right?
Yeah, just common sense, guys.
Excellent, very good. Third of all, folks, we are going to be taking part in some really cool coding activities today. Hopefully ones that you haven't done before. I'm nearly sure you guys haven't done them before, as we're going to be creating our very own probability game. So we're going to develop a game on MakeCode from MicroBit that helps us understand chance and helps us to make informed predictions, right? When it comes to probability, nothing is guaranteed. But we're going to do some experiments this morning that's hopefully going to set us up to basically have the highest chance possible to win some prizes of some sort in our scenario.
I like the sound of that.
You know? And then last but not least, Ryan?
Next, we're gonna automate some multiplication. Okay, so I know you guys probably like your times tables. Me and Michael love our times tables. We like to do little competitions. So what we're gonna do is actually we're gonna code a times table quiz on MicroBit, and it's gonna help us practice our multiplication skills in a fun and interactive way, which is exciting.
When I was in primary school, our teacher used to get us kind of going head to head in tables competitions.
It was very tense.
It was very tense, but I loved it. I loved the thrill of it. And what we're going to be doing today, folks, we're actually going to be using code to kind of get that intensity back, that competition back.
We're going to practice so we can win next time.
There's a lot more practice.
Yeah.
Me and you are going to go head to head today as well. But you and the people around you can actually go head to head in a little bit of a multiplication challenge. And it can all be automated. So instead of your teacher calling out the tables for you, you can actually use the MicroBit interface to kind of call out those questions.
There's no longer an excuse not to be good at your tables.
Yeah, exactly. We're going to have our tables down to a T now by the end of today's session. So, Maths Week, Lorraine, is obviously what we're celebrating today. Be sure to use hashtag #IUseMaths as well, or hashtag #MSDreamspace for everybody joining us throughout today's workshop. But why do we have an entire week dedicated to maths?
That's a really good question.
It's a good question, but before we kind of get into that, let's think about what is math itself.
It's probably the main question.
Yeah. So what is math itself? So obviously we have a whole week dedicated to it. It's one of the core subjects you study in school, but it's not just numbers, right? It's the way of understanding the world around us. And the big thing I always like to think about is math is that it's a universal language. So no matter the language you speak, English, Irish, French, Polish, and so on, there's that math language that everybody can communicate in. So no matter where you are in the world, 1 + 1, no spoilers, is equal to 2.
At least you got that one right.
Yeah. So that's what's really cool. So math is basically the universe's language, which I think is really cool. And it kind of starts to play part in everything that we do in the world around us. I use it quite a lot because I'm big into my video games. So I use kind of like quick math in my head to kind of solve different issues that I encounter in a game and so on.
So as Michael was saying, like, why does math actually matter in everyday life? Like, why is it so important? Well, as he said, like, how do you ever wonder how your favorite video game was made? Or even how, if anyone wants to be an architect, how do they do up all these measurements to make these buildings? Everybody uses math. So me, myself, I love to shop, maybe too much. But sometimes I can go a little bit overboard. So I need to make sure that I stick on budget
Yes.
and I don't run out of money before the end of the week. So for that, I kind of use my maths and I see, well, how much do I have left over? So that's kind of important for me. I kind of solve a problem and it's definitely useful. But also we can make cool things, like engineers and architects can make cool buildings using maths, which I think is really, really interesting.
Exactly, yeah. So again, we want to kind of get you out of the thinking of math is just the sums you do in your copybook or what you learn about in school.
Definitely not.
Everyday life, and those skills can really stand to you no matter where you go. Third of all, what exactly is Math Week? Well, it's a very special week. It's celebrated every single year, and MathWeek.ie are a fantastic organization who look after it, and they have some amazing resources. But it's basically about getting schools, universities, even public places hosting fun activities to make math more enjoyable, which is hopefully what we're doing for this workshop.
I hope so.
as well. And then last but not least.
So yeah, what is the purpose of Maths Week? We want to show you guys that maths is just not all about your book and your exams and like people I think it has like a bad name. I think it's boring or whatever. But like it's actually really fun. We can explore the fun side of it, and we're going to do some cool projects using maths, using microbit. And we're also going to show you how we use maths in real life and how it can be really, really useful.
Exactly. So myself and Lorraine have been having kind of good discussions there about our love for maths, right? Our personal passions for it. But it's time now for you guys and to share your thoughts. So you see on your screen right now, you have two questions. The first one being, can you name a situation or job where math skills would be essential? And then your second question is, why do you think maths would be important there? So whatever example you give, let us know how you think math play a part in it. Now, what's really interesting here, Lorraine, is that obviously math plays an important part in your studies, or if you're a math teacher, as you are, it plays an important part. But we want to hear from kind of like maybe some obscure kind of opportunities in life or situations where, do you know what, math actually comes into play here. So we're going to be really kind of giving good shout outs to people who kind of give those good ideas, right?
Be creative with it, I suppose.
Be very creative with it, yeah. Think outside of the box. So what we want you to do now, folks, is just take a moment and pause and discuss those questions you see on your screen, and be sure to think, pair, share. So think about your answer, pair up with someone around you, and then share it with your class. And let's look at the connection between maths, STEM, and coding. So first and foremost, in this kind of this trifecta, the math, STEM, and coding, we have math. It is the cornerstone, right? It is the foundation that we build everything on top of. So in the realm of science and engineering, having good math skills is really, really critical, right? For understanding patterns, solving problems, and making logical decisions, like you said earlier on. And as we said, logical decisions are just decisions that are made with a little bit of sense.
Yeah.
And then even in advanced fields like quantum physics and robotics and so on, they aren't just these brand new instructions that you only learn about when you get there. They're all based off of simply simple sums, simple
They're building on the
multiplications.
basics, I suppose.
They're building on the basics, exactly. So that's what's really, really important, to kind of invest in good kind of math foundations at an early age. So when you're a student in school, so that when you go into these fields, when you start building your own robots, you have those skills to kind of be able to do it, right? Next of all, Lorraine, we had STEM. So in Dream Space, we obviously love STEM.
I love STEM, yeah. So Michael, what does STEM stand for?
STEM stands for science, technology, engineering, and math.
Yeah, so this is kind of where I suppose our coding and our math are like intersecting, where the crossover happens, okay? So we're using STEM to solve real world problems. For example, like there we have civil engineering. We need to use it to make sure if we're building a bridge, that our bridge can withstand force and that it's not going to fall down. That's really important. And also to make sure we actually make it across the river. We don't want it to go halfway, that wouldn't really work, okay?
Yeah.
Another example could be if you're like a software developer in the planning stage, to make sure that your technology lines up and that all the calculations make sense. So you can kind of see where they overlap there.
And then last but not least, we have coding. Now, if you've never heard of coding before, folks, I know some of the schools joining us have done a little bit of coding already, but if you're brand new to it, don't worry. Coding is essentially the language we use to communicate with computers. So again, as I said earlier on, we have a range of different languages to talk to each other and communicate with each other. Coding is just the language that we use to tell computers what to do.
Exactly.
Okay? And that's the bridge between real-world applications of STEM and then those mathematical skills. Because a lot of the time what we do is we come up with an idea in maths, in the concept, in the theory, and then we use code to be able to put that to tell a computer to solve it for us, or give the instructions to a robot, or even kind of different types of software. And it can go from simple calculations, right? So simple calculations to do those sums for us. We'll actually be doing some of those later on.
Yeah, can't wait.
All the way to complex data analysis. And
Yeah.
we'll be doing a little bit of data analysis later on as well. And I think kind of a good fact to note is that according to code.org, more than 60% of all STEM jobs, so in the world of science, technology, engineering, and math, require or involve computing. So, it's really important
It's really
to have those
important
coding
skills to have, 100%.
Yeah, so exactly. So not only is it important to kind of look at math as a foundational subject, but then as you're going, coding is going to be allowing you to kind of bring some of those mathematical ideas to life.
It's also really fun, so
Yeah.
that's a bonus.
Yeah, exactly. Yeah, we can't reiterate enough.
Yeah.
So folks, before we kind of get into a little bit of a warm up with word problems in just a second, what I wanted to draw your attention to was something really cool, all right? You would have heard or you've done a lot more math at this stage than you would have done coding, all right? Because you're still in school. However, as we said, there's a huge crossover between maths and coding, so much so that there's ideas that exist in both. And the first one we have, Lorraine, is something called a conditional statement. Right? Big fancy term. You may have heard of them before, you may not have. But in mathematics, a conditional statement is like a promise, basically. Right?
Okay.
It's like a rule that's already set in stone. So if you do this, then this will happen.
Okay.
Right? And I'm sure as you guys are learning math, you're learning more and more about these rules, right? But it's simple as it can be as simple as, okay, if an even number is divided by number 2,
Okay.
how much remainder do we have?
0.
It's always going to be 0, right? So that's the conditional statement. That's the rule that's kind of set in stone.
So it's always true and it never changes.
Exactly,
okay.
Yeah. But then in the realm of coding, Lorraine, what do conditional statements mean?
It's a similar kind of idea, but slightly different, okay? Yeah. So a conditional statement, it's a coding instruction that works only when a specific thing is true, okay? So let's just say, for example, if we're designing a video game, Michael, okay? So I could say for my conditional statement that I only move up to the next level if I score over 100 points. So if I score 99, I'm not going to move up. But once I pass the 100 mark, I get to go to level 2.
Yes.
That's the conditional statement that I set for my game.
Yeah. And what's cool about those is that we make the rules for conditional statements in coding, right? So unlike, every time a number is even, it's going to be giving you a no remainder when you divide it by 2. But in the realm of coding, when it comes to conditional statements, we're the ones who kind of build that logic, right? So telling a computer what to do if a certain condition is met. Think of it like this, right? When you wake up in the morning, you look out the window.
Yeah.
If it's raining, then I'll wear a rain jacket. Else if it's cold, I'll wear a hoodie. Else I'll wear a t-shirt because I'm going outside, okay? So those are just the different kind of conditions that if they're met, I'll do something different. And the same can apply for our computer, right? So making the different decisions based on what's going on around it. Now, next of all, we have loops.
Loops and patterns, yeah. So in maths, Michael, a loop or a pattern is just a repeat that keeps going in a way you can predict. So let's just say if we're talking about our times tables, okay? So if we go 2, 4, 6, 8, 10, 12, that's my 2 times tables. But as you can see, each number is predictable. So it's kind of following a certain pattern, okay? Yeah. So we always see that the whole time in maths when we're talking about patterns.
Yeah. So it's really, really important. I'm sure pattern recognition and spotting patterns, I think people are starting to realize now, the students join us, okay, patterns are really, really important when it comes to like even geometry or shapes and that kind of stuff.
I love solving patterns. It can be really fun.
And speaking of those patterns, we actually incorporate something called loops when it comes to coding when we find those patterns. So if we find something in our instructions that we're given to our computer that's being said over and over and over again, and instead of me having to drag out the same blocks or writing those instructions over and over again, I can use something called a loop to have it repeated for us, right? So like going up in those 2 intervals in our 2 times tables, 2, 4, 6, 8, we can actually automate that process for us in coding by using something called a loop, which is pretty interesting.
That is really cool.
And the last but not least, variables. Now, variables is probably the biggest crossover between math and coding, right?
Definitely,
They're super important for both. Now, in mathematics, a variable is like a placeholder that can be filled with different numbers, right? Now, some of you joining us, folks, you may not have experienced algebra before, and the idea of letters in sums might be a little bit confusing, but don't worry, you'll learn all about it in the future of your studies. But we have a simple one there called x plus 2 equals to 5. Now in this instance, Lorraine, x is a variable, right? Because it can stand for basically, and it's a placeholder that we need to solve. So do you want to talk us a little bit through that equation?
Okay, so here we have like a really kind of basic equation here. We have x plus 2 equals to 5. So if you see there the equal sign in the middle, Michael, that means the left-hand side equals the right-hand side. So we need to think about what number could we put into x, add it to 2, that will give us 5. What do you think, Michael?
And I think that is 3.
3. So
Yes.
3 plus 2 equals 5. The left-hand side equals the right-hand side.
Yeah, so we can then say, yes, exactly. X is our placeholder for the number 3.
Exactly.
But then in coding, a variable is like a storage spot. It kind of has the same kind of idea, right?
Exactly.
It's a placeholder. It can store different kinds of information for us, like numbers or even words sometimes. But the important thing is that it can change what it's stored anytime you can change it whenever you want.
So you could think about it like you're playing like a football game, Michael.
Yes, yeah.
So obviously during the game, the score is changing.
Yeah.
So once, let's just say if we start off 0-0, once one team scores, the score changes. So we can't have like a set value. It has to be able to change. And that's where a variable comes in.
Yeah, and that's what's really cool. But it's still classified and called the score.
Exactly.
Just what it's storing is changing. And that's going to be really important as we get into coding as well. Okay? So those are just some kind of crossover concepts and ideas that are both in maths and in coding. Now, we had a great kind of discussion there, and I hope everybody kind of enjoyed that and took a lot from it. But it's time to put some of those kind of those concepts, such as variables and such as conditional statements, to the test as we take on some logic puzzles and word problems, which we love in DSUpcoming.
We love, yeah.
So you'll see on your screen you have 2 problems, right? The first one is Mary has twice as many brothers as sisters, and John, her brother, has twice as many sisters as brothers. How many children are in their family?
Okay, if you think about this one, that's a little bit tricky.
One. Yeah, and then a separate problem is our second one, right?
So the second one says, a rocket is on a mission to Mars. I don't know if anyone was here with us during Space Week. We did a top secret mission to Mars. So it says the distance covered, it doubles every week as its speed increases. If it lands on Mars in the 12th week, in which week was it halfway there, Michael? See if we can figure that out. So we're going to use our logical thinking brains. And maybe if you want to work in pairs, write down some ideas and see what you think.
Yeah, exactly. So take a moment, folks, and pause and see if you can kind of solve these kind of word problems you see on your screen. Okay, brilliant, everybody. Some fantastic answers coming into the Q&A there. So, Lorraine, you're going to give us the big reveal, right? A lot of people got those right in the Q&A. So, Mary has twice as many brothers as sisters, and John, her brother, has twice as many sisters as brothers. How many children are in the family?
Okay, so this one sounds like a bit of a tricky question.
Is it, yeah.
Kind of mess with your head a little bit. But let's just think about it. Let's just say if Mary has one sister.
Okay.
Does it make sense that when Mary has one sister, John has 2, because Mary is also his sister?
Okay.
Okay. Similarly, if John has one brother, then Mary has 2, because John is also her brother.
Okay.
Okay. If we double 1, Michael, what do we get?
We get 2.
We get 2. So that must mean there must be 2 sisters and 2 brothers in the family.
So 4 children in total?
Exactly. 2 plus 2 is 4.
Excellent. Very good. And I think that was kind of a good kind of look at conditional statements there. So you're saying like if Mary had this, else then if John had this, and so on. It's very good. Next of all, then we had our mission to Mars. So a rocket's on a mission to Mars. The distance covered doubles every week as its speed increases. If it lands on Mars in the 12th week, in which week was it halfway there?
Okay, so does it make sense that if every week we move forward, we're doubling?
Yeah.
Then that means that every week we move back, we must be halving our distance.
Okay.
So let's just say if I've gone the full way in week 12, if I move back only 1 week to week 11, I'm halving my distance. I'm back at the halfway point.
So we are halfway there on week
11.
Wow. Okay, very good. Our mission to Mars really starts taking off as we nearly near
really
our
making
right.
up for lost time again.
They leave it to the last minute to make it halfway there. Okay,
Exactly.
very good. Great stuff. So just to recap, folks, question number 1, there's 4 children in the family. And then question number 2, it's on week 11 that you're halfway to Mars.
And a lot of students did get that one, so well done. It was tricky.
Math, well done for everybody on those real kind of brain teasers there.
Yeah, definitely.
You have to really use your logical thinking there as well. Okay, excellent. So, Lorraine, are you ready to look at today's projects?
I'm ready.
So, today's project, Lorraine, is actually inspired by a little story, right?
Okay.
So the last day I was in the supermarket, I was in a shop, and I was down the cereal aisle.
Okay.
And they were advertising on one of the boxes of cereal, which I can't remember at the moment, that there was 3 collectible kind of like special cards that can be found in the cereal box.
Okay.
Now, this reminded me of years ago, you used to be able to collect toys from those cereal boxes.
Yeah, I remember that, Michael.
I used to love those,
Loved
right?
it.
So there was 3 unique toys that you could get from the cereal boxes, but it was completely random, all right?
Okay.
So you couldn't see, all right, this one is a green label, so it has this toy and so on, right? It's completely random. The packaging is the exact same, all right? So I started thinking, all right, how many boxes of cereal would I need to purchase to nearly, have a higher chance or nearly guarantee that I would get all 3 toys?
So to have an idea in your head how many you should buy, okay?
Yeah. So what I started to think about was, all right, I think I can use the MakeCode to help me out here.
Yeah,
right?
you could.
So we came up with this little bit of challenge that everybody is going to be working on. So it's the toy collection challenge. So your mission is to create a simple simulation using MakeCode for MakeCode that mimics collecting toys from cereal boxes.
Okay.
So in this challenge, each cereal box contains one of 3 different toys. And the goal is to find out how many boxes you need to open on average to collect all 4 toys, or 3 toys in this case.
Yeah.
Right?
Start off small.
Yeah, we start off small, and if we have time, we'll go to 4 toys as well. Okay? So, keeping that in mind, Lorraine,
Okay.
is there any way we can guarantee we'll collect all toys?
We can't guarantee it.
Yes.
Does it make sense that even if we opened 100 boxes of cereal, they could be all teddy bears for all we know, but we can kind of have an idea and we can kind of see by doing different trials, on average is the important word, how many boxes we should buy.
So basically what we're going to do is we're going to conduct some experiments using a microbit program to kind of give us a good idea of how many boxes of cereal we would need to buy, the minimum, to nearly have a high chance to collect all those toys.
I think someone said earlier in the Q&A, they said that scientists use maths. So we're kind of like scientists
we're
using
going to be
maths right
taking part in
now.
some
We're doing
experiments. Excellent, very good. So we're going to be working with makecode.microbit.org. So we're going to take a moment now and pause and allow you guys to open up your devices and go to that URL, makecode.microbit.org. Once you have that website open, pause there, and I'm going to give you a walkthrough of how we're going to take on this challenge. Yes, exactly. So we're on MakeCode for Microbit. If you've never heard of this website before, Lorraine, it's fantastic.
So good.
It's a free browser-based coding platform that supports 3 different languages: block-based coding, JavaScript, and also Python programming as well. There's no sign up and there's no sign in, and there's no need to even download any software. And you can code directly through your, just with an internet connection and a browser, which is amazing.
Makes it very easy for us, which is good.
Yeah, it's going to be really easy for us. So it's going to be brilliant. So this is the website you're going to be looking for. On the top there, we have a little carousel of all the new features that MakeCode for Microbit has added. And if you scroll down, there's a range of different tutorials that you can take part in as well after today's workshop. But what we're going to be doing is we're going to be clicking New Project. And then we're going to give our project a name.
Okay.
What was the name of our challenge again?
Do we have a name for it? See, the cereal challenge.
It was the cereal challenge. It was the toy collection challenge.
Toy collection challenge.
Yeah. So it's our toy collection challenge, and that's what I'm going to call my project. All right. I
guess they can call it whatever they want.
Yeah, you can get creative. You can name it whatever you'd like. What I would say is, don't get too worried about naming your project. Just name it whatever. So I've reset my MakeCode for Microbit website, so it's giving me a little pop-up for a tutorial. Let's briefly take part in this little tutorial in case anyone who's joining us it's their first time on the platform. So let's take a tour of the editor. Over here on the left, we have our Microbit simulator. And what's amazing about this is that you don't actually need those physical microcontrollers, those physical microbits hardware themselves, because our simulator here can run all of the code for us without the need of anything, right?
Okay.
Excellent, right? Next of all, we have our toolbox. So this is where all of our blocks, our code are going to be found. Now, as I mentioned, we're using block-based coding, so everything is color coordinated. And if you see me use a block and you're wondering, where did Michael and Lorraine get that block? Just look at the color and you will find it in the category that it corresponds to. Over here is our workspace. So this is where we're actually going to be snapping blocks of code together and where we're going to be placing our blocks of code. As you can see, there's 2 blocks already in place: on start and forever. These are C-shaped blocks, but they're also called event blocks, as they tell our simulator when to run the blocks of code we placed inside of them. Next of all, folks, after you finish today's program, you can actually hit that share button at the top to share your program as a URL to maybe your teacher, your adults at home, or even to yourself if you want to change devices. If you have the Microbit hardware, you can click the download button in the bottom left to actually flash it onto that piece of hardware, that microcontroller. But if you don't have microbits, don't worry. Our simulator can still do all of our code for us. And congratulations, we've completed our
Success.
So that's our first piece done. So we're going to get stuck right into it, folks. And we're going to start thinking about our challenge that we're taking on, right?
Okay.
The toy collection challenge. So on Start and Forever, they're amazing, right? They're really good blocks.
Yeah.
But we're actually not going to need them for this piece of work.
No.
So what we're going to do is we're going to click on Start, drag it over to the center, and put it into our categories and recycle it, okay? And then I'm going to click on Forever again, drag it over, place it into our toolbox, and recycle it, and it gets rid of it for us.
Okay.
Now, what I want to kind of emulate here, right,
Okay.
for our program, is the idea of like shaking open a box of cereal
Okay.
and a new toy falling out.
Okay.
And the cool thing about that is our microbit can actually kind of emulate that shaking feature by going into inputs. Now, in inputs, Lorraine, it's how our microbit takes in information. And the same can be said for all hardware,
Yeah.
right? All computing. Inputs is where the microbit takes in information from the world around it. And the microbit actually has a sensor called an accelerometer. So if you shake it, it actually knows it's being shaken and also how hard it's being shaken.
Oh.
Pretty impressive.
That's really smart.
So what we're going to use is we're going to use an event block called onShake. And we're going to place it just here, okay? Just like that.
Makes sense.
Now, for anyone who's joined us for previous DreamSpace Lives, I'm actually going to approach this a little bit differently today. Right?
Okay.
Instead of me showcasing to you a step-by-step guide of how to create the program, I'm just going to first of all show you all the blocks you'll need. I'm not going to connect them.
Okay.
I'm not going to put them together. And then I'm going to give you the opportunity to see if you can solve that puzzle and put them all together.
Oh,
like
it's a bit of a challenge.
Yeah, like
Okay.
a jigsaw. So you're going to be using those logical thinking skills. That's super important for Maths Week this week. All right? Now, we will give you a moment to pause and take part in that.
Yeah.
And we'll come back and we will show the solution.
We'll give you a hand.
So if you're having trouble, we will help you. All right? So onShake is going to be our first one.
Okay.
Next of all, Lorraine, we want to think about it, right? Our microbit's smart.
Yeah.
It has sensors that can pick up light, heat, sound.
Okay.
But what I can't tell is a toy. I can't
can't, no.
identify a toy. So what we need to do is we need to basically associate the toys that we're collecting into something the microbit can understand,
Okay.
which will be numbers.
Numbers.
So computers do understand numbers, right? Numbers, maths, the universal
very
language.
fitting.
Yeah. So let's just first of all decide what's going to be our 3 toys.
Okay.
Our first toy is going to be classified as number 1. So what toy do you think we should use?
Teddy bear?
We should go teddy bear. Number 2 could be?
Maybe a toy car?
And then number 3 could be?
Football?
Maybe a football, okay? Would that be a big
Maybe
box?
a yo-yo.
A yo-yo, okay, cool. So let's say teddy, toy car, and yo-yo. You guys can decide what toys you want to include in your cereal boxes, all right? So what we need to do is we need to create a piece of code that refers to those toys.
Okay.
And we're going to store information inside of it.
Okay.
And we looked at a concept on that earlier on. Can you remind me what it was, Lorraine?
Was it a variable, Michael?
It was a variable. So we're going to be clicking on our variables category, and then we're going to be clicking make a variable, because this category looks a little bit different to the other ones. So I'm going to hit make a variable, and then we can name our variables. So I'm going to call my variables toy, right? And when I hit OK, I get 3 options.
Okay.
It's set toy to 0, change toy by 1, and then a roundy toy block.
Okay.
Now the first thing we want our program to do is to decide which toy I'm getting.
Yeah.
Is it the first toy, the second toy, or the third toy? The teddy, car, or ball?
Okay.
So we need to keep in mind the sequence of our code. So the first block I'm going to drag out is set toy to 0.
Okay.
And I'm going to place it just here. It doesn't matter where I'm placing it, because remember, folks, I'm not creating the program.
Not yet.
I'm just showing the tools that you're going to be using, right? So it's going to say set toy to 0. Can you tell me maybe, Lorraine, why is it gone all that yellow and grey color?
Well, do you see the shape of that block there, Michael?
Yeah.
Okay. So the problem with that is that that actually needs to go inside my event block, okay? So we need to fit it into our C-shaped block, and then once we do that, it will turn the right color.
Life,
Yeah,
right?
exactly.
So we're not going to do that just yet. We're going to leave that in your hands. Right?
Okay.
This is a bit of a challenge for you. So the next thing we want is we want our microbit to pick randomly between 1, 2, and 3.
Okay.
And very fitting for the week that's in it. Do you know where we're going to find the random block?
I'll make a guess.
Yeah.
Maths?
Yes, it is. Right? It's our math category. So if we go into math, we can scroll down and we can find a roundy block that says pick random 0 to 10. I'm going to drag it out and I'm going to place it just there. Okay?
Okay.
Just like that. Now, next of all, after our microbit program has set it to either be a toy or be a teddy, a car, or a ball. I want it to then decide if it's going to be what it shows us to tell us what we've got.
Okay.
Right? So it's set it as a number.
Okay.
It's time now to tell us it's a teddy or a car or a ball. And those are, if it's 1, then it's a teddy.
Okay.
Else if it's 2, then it's a car.
Okay.
Else it's a ball.
So we're going to assign a number to a toy.
Yes, so we have
Okay.
our numbers. So that means I'm going to have to change my pick random block to 1, 2,
3.
3. And it also means, because I use some keywords there, if, then, or else,
Okay.
we're going to be incorporating what?
Logic.
We're going to be incorporating logic, like we discussed about those conditional statements that we talked about. Okay? So I'm going to drag out if true then, and I'm actually going to place it here. Now that's not the correct sequence that I'm going to have it in my final program,
No.
but I'm just laying out all the tools for you all to take part in. Now, as you can see, Lorraine, there's only 1 slot there.
Yeah.
How many toys do we have?
3.
3. So I need to click on my little plus icon 2 times. And now we have 3 slots.
Okay.
Okay? Okay, perfect. So last but not least, we have to then decide what we're going to show our microbit
Okay.
on our microbit to show us what toy we've got.
Okay.
So I'm going to go to basic and I'm going to drag out show LEDs. I'm going to place show LEDs just here. And as a sample, I'm going to draw a little teddy bear.
Michael the artist.
Michael there. Yeah, please don't judge me for my skills. They might not be the best. Just going to do this. Then that kind of looks like a teddy bear. So that kind of looks like a teddy bear.
I think it's good.
So it's nearly there. And then last but not least, we then have to tell our microbit, okay, if our variable toy is 1, then do this. So we need to have that equal sign, like we looked at earlier on with our equation.
Maths again.
So we're going to go into our logic, and you will find that 0 equals to 0. Dragging that out, that diamond block, I'm going to place it there.
Yeah.
0 equals to 0. What we want in that first 0 is our variable.
Toy.
I'm going to go toy. Now, those are your tools, folks, right? The blocks you see on your screen is how you're going to complete the toy collection challenge. We're going to give you guys maybe 5 minutes to see if you can figure out at first. Yeah. And then myself and Lorraine is going to come back. We're going to put all those blocks together. We're going to solve it. And then we're going to see what we're going to do in regards to data collection as well.
Exciting.
Right? So we're going to take a moment now and pause and see if you can complete the toy collection challenge with the blocks you see on your screen. If you have any issues, definitely let us know. Okay, brilliant stuff, folks. So what we're going to do now is myself and Lorraine are going to start putting these blocks of code together. So remember, let's think of it logically, and then think of the sequence of our code, right? So that's really important. So if you aren't familiar with that term, it's basically how our computer reads from top to bottom, right? Like the majority of us do.
Yeah.
So think of algorithms and think of computer programs kind of like a recipe. So you start with step 1, step 2, step 3, and so on. Speaking of, we need to think of our first step of our program. We want our program to decide what toy, after we shake the cereal box, is going to come out, right? So we're going to be setting our variable at the very beginning, okay? And as you can see, now that I've connected it to an event block, it's brought back its normal red color, right? Now, remember we decided there was 3 different outcomes or 3 different conditions, us getting a teddy, us getting a car, us getting a ball. We're going to have to pick this, drag in this pick random block just in here to set that toy to randomly pick as we go, all right? That's quite cool. And again, probability is a really, really important concept in mathematics. Lorraine, can you tell us a little bit about probability actually, as we're just using the blocks here?
So all probability basically is a measure of how likely it is that an event will occur. Okay, so let's just say if I flip a coin, what's the probability of getting a heads? 1 out of 2 times.
Yes.
Okay, so that's a basic example there. And yeah, we're going to be looking at that now.
Yeah. So then now that we have our variable being set to 1, 2, or 3, our teddy, car, or ball, every time I press shake, it's working for us. So as you can see, it's always important to test your code as you go.
Yeah.
But it's just, nothing's been shown on our microbit because we haven't told our microbit to do it.
Yeah, we have to tell it to do
exactly.
everything.
So I'm going to drag in our conditional statement, and I'm going to bring it back to life by snapping it underneath my variable block, which sets it randomly. So now it says if true then, else if, then, and then finally else. And these are our conditional statements.
Okay.
Remember we talked about those earlier on, okay? Now, in the sense of block-based coding, think about that logical thinking again. You should be able to read it, and it should make some sense, right? If true then. We haven't talked anything about true or false today,
no.
right? What we are talking about though is if our toy variable is 1,
Yeah.
then it's a teddy.
Exactly.
So we know now to place our diamond block, which gave us that equals to sign, inside our first condition.
Okay.
Right? And now I can replace that first 0 with toy. Okay? So now it's starting to come together. And now I can say if toy is equal to 1, then I'm going to get myself a teddy bear.
Nice looking teddy bear.
A nice looking teddy bear. I wonder how creative everyone else is getting on with their LEDs. All right? And now I just repeat the process. I can go back into logic, drag out my 0 equals to 0, and then drag out my toy into my first slot there. And this time it's going to be if it's set to
2.
Yes. And if you remind me, Lorraine, what was our second option?
A car.
A car. So I'm going to go into basic, drag out show LEDs, and make my best attempt at drawing a
No pressure,
car.
Michael.
Okay, here we go. This would be the bonnet, body of the car, 2 wheels.
Oh, I like it.
Looks more
I
like
see
an
your
alien
vision.
from Space Invaders more than a car. But let's say it's a car, right?
Okay.
Or maybe a UFO.
Yeah.
Our UFO toy. Okay, perfect. Now, Lorraine, I'm sure a lot of people have encountered this and they're wondering, why does the final statement, which should be our ball,
Okay.
why does that not have it if toy is equal to 3 then?
Because we only have one more option left, Michael. So it's just going to be the default. If none of them happen, then whatever the last option is, that will go into the last one.
It's really important, folks, to note that when you're working with conditional statements, always have an else statement at the end.
Yeah.
That's our safety net, right? And in this case, it makes sense, and everything should make sense.
Yeah.
If the toy is not 1 and it's not 2, then it's going to be 3,
Yeah, it has
which
to
is
be.
our ball. And that means else can fulfill that statement for us. So I can drag this down, place it into my final one, just there. And now I'm going to draw a little ball.
This one's a little bit easier.
This one is definitely a little bit easier. Now, the important thing to note is I need to test it. Right? I'm going to go over here. I'm going to press, I'm going to refresh just like that. I'm going to press shake. I get a toy car. Press shake again, get a teddy.
Okay.
Press shake again, teddy again, and then a toy car. I'm going to keep pressing until I get my ball. Okay, now I know that the 3 conditions do appear.
They work.
So I'm happy out. My program is now complete. However, what's interesting about this challenge, Elaine, is that my program isn't the solution.
No.
It's just a means to an end.
It's a tool.
Yes, exactly. So we're using our code as a tool today, which is really important. So we're going to start thinking about now, okay, I'm in that shop.
Yeah.
I want all those toys, right? I'm very much a collector, I should say, right?
Okay.
And I want to collect all these different toys from the cereal box.
Okay.
Is there a way I can guarantee I get all of them?
There's no way to guarantee it, Michael. Okay, we're just trying to improve our chances, I guess.
Okay, so is there any experiments I could do to kind of give me a good rationale and so that I don't break the bank buying thousands of boxes of cereal? Is there any kind of experiments I can conduct to be able to tell me, all right, if I buy this many boxes of cereal, I have a high chance of getting all 3 toys?
And what I think we could do is we could maybe do a few trials, okay? So we could maybe shake the micro bit and see how many times it takes for us to get all 3 options.
Okay.
We could repeat it a few times. Maybe just for today, we could do it maybe 3 times.
Yeah.
But maybe if we had more time, the more times we do it, the more accurate it gets.
Okay.
Then we could see, well, if, let's just say the first time it was 5, second time was 3, third time was 2, on average, how many times did it take?
Yes.
And then we could use that as like a guesstimate to base off.
Yeah. And let's say this is your first time ever hearing about averages, folks. Don't worry. Maths Week is all about exploring new concepts and ideas. Myself and Lorraine are going to quickly just do that, conduct our experiments.
Yeah.
And we're going to give you our estimate of how many cereals we need to purchase, right? So I'm going to first off hit refresh.
I'll write this down.
And then I'm going to go to shake, right? Now I press shake once. I've got my teddy bear.
Okay.
All right. Teddy bear in the back pocket. I'm happy out.
Good to
right?
go.
I've shaken my first box of cereal. I got my teddy bear. Now I'm going to press shake again. And I got a ball.
A ball, okay.
Okay. Now I'm going to press shake again. And I got a teddy again.
Again.
Now, even though I love teddies, I already got one, right?
Okay.
So I want to shake it again. I'm looking for that car now. And I got a car.
There you have it, okay.
Excellent.
Okay,
So how many shakes did it take us to get all 4 toys?
trial 1, it took 4 shakes.
So trial 1, it took 4 shakes.
Okay.
So Lorraine is taking this data down for us, or for me, it's collecting this data for me, or you could do it yourself if you're an individual, or you can buddy up with someone around
Exactly,
you,
yeah.
Right? So let's do that experiment again, Lorraine.
Let's reset it.
I'm going to reset. I'm going to go to shake. Got a teddy.
Teddy again.
I got a ball.
A ball.
I got a car.
Oh.
Ooh, that was a lucky one.
Okay, that was good.
Yeah, I saved a lot of money on that one. All right. And then that's our second trial. That time it took 3 boxes of cereal
3 boxes.
to get all the toys, but I think that was a real lucky streak.
That was lucky.
So let's try it one more time. I'm going to go shake. I got a car.
A car.
Shake again. Ball.
A ball.
And then shake one final time. Teddy.
Teddy.
Really lucky one.
Should we go one more time?
Let's try another experiment. Yeah, one more trial, right? That time it took us 3 times.
Yeah.
Let's going to do one more trial. Okay? Shake. Car.
Car.
Ball.
Ball.
Ball again. Car.
Car.
Car again.
Car again.
Car again.
Oh no.
Car again. Car again. I have a whole racetrack of cars.
Yeah.
One more time. Ball.
Ball.
Ball. Ball.
This last was really messy up, Michael.
Ball.
Ball again.
Car.
Car.
This is hilarious.
We need a Teddy.
Car.
Car.
And then finally Teddy.
Finally, how many times did that take us? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15.
15 goals, right? So this shows you can have a real lucky streak.
Yeah.
Like those other 2 trials. So what we're going to do now is we did it 4 times, Rain.
Yeah.
And it took us 4 cereals the first time.
Yeah.
It took us 3 cereals the next time. 3 cereals the time after that.
Yeah.
And then it took us 15 boxes of cereal for our 4th one, right? So what we're going to do is we're going to get the average. Now, if you've never done this before, Lorraine, can you explain to us how we get the average of something?
Okay, so to get the average of our different trials, what we're going to do is we're going to add up all our numbers together. So like the first go, it took us 4 attempts. So it's going to be 4. Second one was 3. So 4 plus 3, and then 3 again. And the last one was 15. So we're going to add them all up.
Yeah.
And then we're going to divide by the number of times we did the trials. So we did it 4 times.
Yeah.
So we'll have 25 in total. Divide that by 4 to get our average.
And our average is?
It's 6.25, okay? So what I would say is, to be safe, from these experiments, we should probably buy 7 boxes to have a high chance of getting all of them.
And we could probably, how could we actually maybe make our estimate even better?
So the more times we do the experiment, Michael, the more accurate our result will get, okay? And as we said, this is not foolproof, guys. You could buy 7 boxes of cereal and still get like 6 cars, okay?
Or 6 teddies.
Yeah, we don't know. But it's just kind of probably an idea of what to base
It's all about probability.
Exactly.
So what we're going to do, folks, is we're going to pause now for maybe a few moments and allow you guys to do a little bit of data collecting. And we want to hear from you. How many boxes of cereal do you think has the highest probability to get us those 3 toys? If you're finished early, what we want you to do is maybe do a few more experiments. So make it as accurate as possible. All right. Or you can actually start increasing different number of toys that are available to you. So you could do 4 toys or 5 toys, right? So we're going to take a moment now and pause and allow you to complete the toy collection challenge. It's time, Lorraine, to move on to our next project. And this one is going to be a bit more competitive.
Okay.
And we're going to go head to head as we take part in the times table challenge. Right? So your task is to create a times table challenge using MakeCode for MicroBit, and the MicroBit will display a random multiplication problem when button A is pressed.
Okay.
Think of the answer in your mind, or race your friend. Right? So we're going to race each other.
We're very competitive.
And then when B is pressed, the MicroBit will display the correct answer for you to check.
Okay.
It's going to be quite simple to do. The program and the code of it allows us to kind of practice specific times tables.
Okay.
And if you're finished early, you can actually have it do 2 random numbers. So you don't even know what times tables you're going to be practicing, right? So let's get going on that. Lorraine, what's your favorite times table?
My favorite one, Michael, is probably my 9 times tables.
9 times tables?
Yeah.
So we're going to go 9 times tables today. So, all right. So I'm not going to delete my toy collection challenge. What I'm going to do is I'm just going to click the MicroBit icon on the top left. Brings me back to my home page here. And I'm going to click New Project. Okay? And then I'm going to say Times Table Challenge. Okay? And then I'm going to hit Create. Now, for this one, folks, again, same kind of layout. We have our on start and forever. We actually don't need them. Right?
Okay.
So I'm going to click it, drag it, and put them in the bin. Right? Poor old on
I'm
stand
going to
forever.
say.
So what we will do is go into input and drag out on button A pressed.
Okay.
Okay? So on button A pressed, another example of our inputs. It's our microbit taking in the information from a user pressing either A button
Okay.
or B button, because our microbits, our microcontrollers, have 2 buttons on them.
Okay.
So let's think about it logically, right? Our microbit's going to take the place of my old teacher. He used to do times table challenges with us, right? And how they would do it, especially if they're focusing on one number, is they'd say 9 times 3, and then the 2 contestants, or the 2 contestants, me and another student, or the 2 students, will quickly say the answer.
Yeah.
And it's the first one to get the answer correct. And then after you said your answers, the teacher will then tell you the right answer if you were right or wrong.
Yeah.
Okay? So that's what we want to do. So what we're going to do first and foremost is do what my teacher used to do and call out the number 9. So to do that, we can go into basic, and you will see there's actually a block of code just here that says show number, right?
Yeah.
Nice and simple. Drag that out. I'm going to place it just there.
Okay.
Okay. I'm going to go and show number. I'm going to change 0 to 9.
Okay.
And then I'm going to use my multiplication symbol, right?
Okay.
Which is our X. So I'm going to do that by going to basic, show LEDs. I'm actually going to draw my X.
It's a little bit easier than a teddy bear.
Yes, exactly, right? So I'm going to do it like that. I'm going to test my code. It says 9, and then it says multiply.
Okay. So the first half done.
First half done. Now, let's think about it, right? If I knew that my times table was always going to be 9 times 2, I'll have my answer. I need it to be random.
Okay.
Right? And I need that second number to be something I can reiterate through my code and use a couple of times. It has a name, but the information it's storing is going to change.
Okay.
So what do you think we're going to need?
A variable.
We're going to need a variable, right? So I'm going to go back into variables. I'm going to say make a variable, and this time I'm just going to call it number.
Yeah.
Okay? Even though my microbit knows what a number is, we're creating a variable here so that we can store different numbers under this one heading.
So it can change.
Yeah, exactly. So we have 3 options: set number to 0, change number by 1, and then we have our roundy number block. Okay? So remember, think of that sequence.
Okay.
First thing we need to do is we want our teacher, or our microbit, our teacher microbit, is going to have to set that number for us before it then calls it out, right?
Yeah.
So I'm going to say set number 0, drag that out, place it underneath show LEDs, okay? And then I'm going to say, if I put a number in here, Lorraine, right, I know what's coming.
It's really easy.
Right? It's very easy. So we need to do random again, and random is to do with probability, and probability is a concept in what category?
Maths.
Maths. I'm going to go to math, scroll on down, drag up, pick random, place it just in there. And we're going to do 9 times 0 is always easy, so we're going to exclude that one.
Yeah, I think so.
We're going to pick our range, change it from 0 to 1, and then I'm going to leave it to pick random 0 to 10, right?
Okay.
If you're a bit more advanced with your tables, you can say pick random 1 to 11, 1 to 12, 1 to 20, 1 to 30. You can go as crazy as you guys want, right? So, Lorraine, let's test it out. Going to press A, 9 times. Nothing's coming up though. Why is that?
Did we tell the microbit to show us the number?
No, we haven't told our microbit to show us the number or show us what's stored in the variable. So I'm going to go into basic, and I'm going to drag out show number. I'm going to place it just underneath here. And then we're going to use our roundy block from our variables category and place it just there.
Okay, I think that should work now.
Press play, press A, 9 times 9, right? You were about to call it the answer there.
I was getting a bit eager there, Michael.
Competition hasn't started just yet. Now, Lorraine, one thing about this program, I'm always looking to make my program as good as possible. But how my teacher used to do it is they used to like pause, add a little bit of anticipation, right? In between each number and a symbol that they're calling out. So what I'm going to do is I'm going to go into basic, and I'm actually going to add a little pause block in between show number and the multiplication and then our variable number.
We're building the anticipation.
And we're going to change that from 100 milliseconds to maybe 500 milliseconds, which is half a second, right? Do that again, 500 milliseconds, okay? Refresh, hit A, 9 times 2.
There you go.
18.
18, oh. Tricked me on that one.
I'm only joking. So we're nearly finished with that program, folks, but now I want to confirm it, right? So we know it's 18, right? But my teacher used to call it the right answer afterwards to confirm, right? And we're actually going to do that on button B pressed.
Okay.
So we go over to input, we drag out on button A pressed again. I'm going to place it there because they're two different event blocks, folks. It doesn't matter if they're above or below or so on.
Okay.
Right? And I'm going to change that from on button A pressed to on button B pressed. Right? And what we want to do now is we want to show the answer.
Okay.
And our answer is going to be a number. So I go into basic, show number, place it just there. Now I'm actually doing some sums here by multiplying 9 by our variable.
Okay.
What category do you think I'm going to go to?
Maths.
I'm going to go to maths.
So we're going to get the microbit to do the maths for us.
Exactly.
Oh.
Yeah. So I'm going to go into math, and you see at the very top here, it says 0 multiplied by 0. I drag this out and place it just there. Okay?
Okay.
I always know that number 9 is going to be a first number.
Yeah.
But what do you think I'm going to put in my second slot?
We go into variables maybe?
Yes. So we have our roundy variables block and press it just there.
Okay.
Now, the sequence in regards to where you place your on button A press and place your on button B press doesn't matter where you place them on your screen. However, Lorraine, it does matter the sequence in which you press them.
Yeah.
Right? Because it's on button A press is when it sets my variable number.
Okay.
And it's on button B press, which uses what that was set over here in my equation.
So we have to do A before we do B.
Exactly. So always do A, so your competition, your test, and then do B to show the answer.
Okay.
All right? Let's test it. 9 multiplied by 6. Okay?
Can I go?
Go for it.
54.
And let's confirm that by pressing B. It is 54. Excellent.
Okay.
Well done.
It would have been embarrassing if I got that wrong from a maths teacher.
So what we're going to do, folks, is we're going to pause now for a moment and allow you to complete the times table challenge using your microbit. If you're finished early, you can actually have 2 variables to take up both slots, right? And you can have multiplication questions being thrown at you, and it has no set number, right? Or if you want to practice a specific number like we want to practice our 9 times tables, that's why we included 9. And then, when you're finished that and you're happy, challenge your partner. Challenge the person beside you, or maybe even your teacher to a little multiplication off.
I think it'd be a really good way if you were told to like learn your tables for homework. To like practice at home by yourself. I think it's like a really useful tool.
Exactly, yeah. And it's super simple, and you should feel proud that you actually coded it, right? Instead of having to go to maybe like a calculator or so on.
Yeah, I think so.
So we're going to pause now and allow you guys to complete the times table challenge and then actually take part in it. Challenge someone to a little bit of a times table challenge and then confirm that you got the right answer by pressing B. Oh, and me and Lorraine are going to do some head-on competition here now of our table as we take a moment to pause. I will admit, Lorraine beat me.
We were nearly fighting here, guys.
So what we're going to do now, folks, is unfortunately we're going to have to wrap up. I had a fantastic workshop with you all celebrating Maths Week. Before we go, myself and Lorraine want to just give you guys some recommendations for what else you can do to celebrate Maths Week. All right? First and foremost, you can join in all the amazing Maths Week activities that are available out there. So check out Maths Week 2023 or mathsweek.ie or even Idge's Maths Week websites as well for more fun activities and challenges you can participate in.
If you guys liked what we were doing today, why don't you explore the MakeCode for Microbit website and find more coding projects that focus on maths and that can kind of help you improve on those skills.
Exactly. Then, folks, you could even create a math scavenger hunt, maybe for a Friday afternoon. Create a math scavenger hunt around your home or school using clues that require solving math problems to find the next location. Imagine even incorporating some of the microbit solutions.
That'd be really cool,
having different devices around with the microbit programs running on them, they'd be really interesting.
Be creative with it.
Yeah, exactly, yeah. Next of all,
you could also share your learning. So like, why don't you guys make a short video or a presentation about what you learned today? You could share with your class, or else maybe you could share on social media. Maybe your teacher could do that, and you could include the hashtag #MSDreamspace so that we can see it.
We would love to see it.
Yeah, it'd be really cool.
Second to last, folks, you can take a moment to maybe create a little math diary for the week, right? Noting down when and how you use math in your daily life. And we'll be really interested in seeing how you use it maybe outside the classroom,
Definitely.
right? This can help you appreciate the importance of math even more.
Last but not least, why don't you use your new coding skills to teach a friend or family member how to create a simple math game of microbits? Maybe you could create a multiplication calculator with your parents at home. And it's a great way to reinforce what you've learned and to help them improve as well, which is really good.
So folks, from myself and Lorraine, thank you so much for joining us, and we'll see you at the next DreamSpace Live event. Stick around as we will be showcasing some upcoming DreamSpace Live opportunities that you can scan and register for right now. But I've been Michael.
I've been Lorraine.
And we'll see you at the next DreamSpace Live.
Thanks, guys.
Bye.